well. Alright, so next, trends in electronegativity. This is just simple. Okay. So electronegativity, you already know this from high school. It is the relative tendency of the atom to attract the shared electrons to itself when chemically combined atau reacting with another atom. Okay. So electronegativity increases up a group and across a period. This follows the trends of ionization energy and electron affinity. Okay. So maksudnya ini adalah sambungan daripada ionization energy lah. Okay, sama je konsep dia because we are going to play with the concept of atomic radius, okay, across period and down the group. So the first 3 points here, we are going to talk about atomic radius punya explanation, okay. So you know that across period, the nuclear charge increases, okay, banyak lagi punya number of proton increases. So ZEF increases. So that means your atomic size will decrease, makin lama makin kecil. So you know that the electron, okay, going from element to element across the period, it is held even more tightly to its nucleus. Alright? So makin lama, makin kecil elemen awak, atom awak. So the electron makin lama makin rapat lah dengan nucleus. Kan? Held tightly. So therefore, okay, the ability to attract electron atau electronegativity of your element increases across the period. Okay, makin lama, makin tinggi electronegativity awak. Okay, increase. Down the group pula, you know that the atomic size will increase, right? So down the group, your electron makin lama makin held less tightly to the nucleus. Okay, the force of attraction between nucleus and electron becomes weaker going down the group. So the electronegativity or ability for your element to attract its electron to itself will decrease. Okay. The most electronegative element within your periodic table will be fluorine atom. So dari sini kita tahulah yang fluorine atom ni, it is very very small. It is in group 17. It's very very small because it is very very electronegative. So maksudnya elektron dia peluk kuat sangat. So to itself, okay, it is very electronegative. Maksudnya they have such a negative charge. Okay. Right. So this is just to tell you that, okay, as atomic size increase, your electronegativity decrease. Okay, it is inversely proportional. Atau as your atomic size decrease, your electronegativity increase. Okay, so this is your periodic table. Okay, now we're going to go to the final learning objective, which is acid-base character of oxides in period 3. So in period 3, we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and chlorine. So what you need to know is that what happens when these elements, okay, react with oxygen. What kind of oxide will it form? So in this case, sodium and magnesium will form, when reacting with oxygen, will form basic oxide. Okay, aluminium special ni sikit, dia 2 alam. It will form amphoteric oxide when reacting with oxygen. Amphoteric maksudnya it can react as both acid and base, right? And then these elements here will form acidic oxide. Okay, so maksudnya bila dia react dengan oxygen, okay, let's look at the formation of basic oxides. As for sodium, bila dia react with oxygen, it will form your basic oxide. And we know that this oxide is basic because when we react it with water, we will form base. Okay, so you need to know the equations. Alright, so basically kena tahulah ini metal ni react dengan oxygen akan dapat basic oxide. Okay, and then react with water, you will get your base. Magnesium pun sama, same case, you will form your basic oxide, and then when reacting with acid and base, you will get salt and water. Okay, for MgO, I'll react dengan acid lah, right? Next, your amphoteric oxide is aluminium. Okay, aluminium saja. So your aluminium, when you get an aluminium Al2 aluminium oxide, okay, Al2O3, when you react with acid, you will form salt and water. When you react with base, you will get not salt and water, but sodium aluminate. Okay, but in this case, you just have to realize that your Al2O3 is amphoteric, okay, oxide, because it can neutralize acid, both acid and base, can act as both base and acid. Macam tu. Okay. Next, for these elements, silicon, phosphorus, sulfur and chlorine, when you react with oxygen or burn in oxygen, you will form acidic oxides. Okay. So this is your acidic oxide, acidic oxide. Okay. So bila react dengan base, you will get salt and water. Okay. So. Okay. So ini bila awak punya acidic oxide react dengan water, you will get your acid lah. Okay. So these are different situations, okay, different conditions when you react with limited oxygen, your phosphorus too, you will get phosphorus acid. But if you react your phosphorus with excess oxygen, then you will get this oxide, and when you react with water, you will form phosphoric acid, okay, which is much stronger acid lah. Okay, so same case like here, for sulfur you will get sulfurous acid, and for chlorine you will get perchloric acid. Okay, so this is a summary table for acid base oxide formations. Okay, so I think it's quite straightforward lah. You just have to know which element you are reacting, okay, and forming which oxide. Alright, okay, so this is an exercise for you to do, and with that we have finished chapter 3. Alright, so you can finish up the tutorial questions for chapter 3. Thank you everyone.